welcome back, and this is my Centurion mini computer. In 1983, this would have set you back $50,000 minimum. That's like 150 grand in today's dollars. Now, granted, today 150 grand for business level or enterprise grade stuff is kind of like a drop in the bucket, but that seems like an extraordinarily huge number to the average person like me. $50,000 is a huge number to the average person like me. In 1983, that must have seemed out of this world for a computer. So what could $50,000 in 1983 get you? I mean, aside from the obvious blue and wood grain aesthetic that is absolutely gorgeous. And you know what? Little aside here, that's something that modern computers need. We need more wood grain in our stuff. Somebody get LGR on the horn. I'm sure he can swing that. But what would 50 grand have gotten you in 1983? Well, this isn't exactly a perfect example because Centurion was building these systems as far back as 1972, and this particular machine has pieces on it as far back as 1975. But the CPU in this is from 1983. That's what the build date on it is. And so that's as good a place as any to look at what kind of horsepower this thing is packing. It is an AM2901 based bit slice processor. Now that bit slice ALU that they're using only has a few instructions, so it's using that with the microcode to emulate a much larger instruction set. Still, 5 megahertz, 8 bits seems a little pedestrian for 1983. But the CPU is constructed in a very interesting way. What this thing does better than nearly anything else out there at the time was multi-user capability. This CPU and operating system can support up to 32 simultaneous users. That's like having 32 Z80s spread throughout your entire office, all networked together using the same storage solution. Now, granted, with 32 users simultaneously using the system, the CPU is gonna chug. And it seems that whenever Centurion sold these systems, they tended to sell them with between 8 and 16 users. And the way that the register context switching is set up, 16 users would be absolutely no problem whatsoever. So it's actually more just like having 16 Z80 based systems throughout your office, all networked together, sharing the same storage solution, which is still pretty bonkers to think about. But that storage solution is another interesting point there. And the primary drive that I'm using on this is just 10 megabytes. That's this drive down here. It is a CDC-made Hawk drive. But this drive actually hails from 1978, and they were making the 9427H Hawk even earlier than that, into the real early 1970s. But again, we're talking about 1983 here. So let's take a look at some of the 1983 drives that I have. Right above the Hawk drive, we've got an 8-inch floppy drive for simple, easy backup and storage. But right next to that 8-inch floppy drive, I have a CDC-made Finch drive. This uses 8-inch platters, and it's a completely sealed hard drive. And this one has 32 megabytes. Now that is a lot of storage, but we can actually do even better than that because right over here, we have the CDC-made Phoenix drive. Now this Phoenix drive currently doesn't work. That's on our to-do list, but it affords you 80 megabytes fixed and 16 megabytes removable. So right here, in these two cabinets, I have around 150 megabytes of storage just waiting to be used. That is a phenomenal amount of storage for 1983, and the system could support even more than that. The FFC controller that I'm using to control the floppy drive and the Finch drive can support up to 2 more Finches, which can give us 100 megabytes of Finch, and the CMD controller that I have in here controlling the CDC Phoenix drive could support up to 2 more Phoenix drives. So you could get 300 megabytes total there, plus the 100 megabytes from the Finch. So we're rapidly chasing down nearly a half a gigabyte of storage just with the cards that I currently have in the backplane. That's ridiculous for 1983. So that is why this machine was so special. But there is one thing that home computers can do that this machine can't, and that is game. Sure, we found a copy of Lunar Lander and Hammurabi, which was rewritten as King, on a removable platter, but I want something that maybe is a little more faster paced. And I think CNake is going to be the perfect example and stepping stone into a larger world of gaming on the Centurion. But I just spent a bunch of time talking about how the strengths of this machine are big storage and multi-user. So single user CNake doesn't really make a whole lot of sense. we should build multiplayer co-op Snake. That's something that I don't think has ever been done, and I am 100% certain has never been done on a Centurion. So we're breaking new ground today. We're gonna try and get multiplayer Snake running on as many functioning data terminals as I have in this room and see, oh, it's gonna be cool. It's gonna be cool. I'm running out of words to say, so let's just hop into it. All right, we're fully spun up and into the operating system here. If we just do a .sta, we can get a status of the machine. We can see up here total system RAM 256K. We have one terminal set up, CRT0, and then here's all of our drives. We've got Data 6 and Soft Term. These are the two platters of the Hawk. We have FUDSDD, this is our floppy drive, and then Torty here is our Finch at 32 megabytes. But the reason that I'm spun up here is that I want to look at the code listing for our game. And if I do a .dir1 here, you can see we've got, well, we got a bunch of stuff in here, and I just so happen to know that I put the code listing in the folder called Usagi. So if I do .dir usagi.1, then we can get the directory listing of that folder. And there it is right there, ZC Snake. So if we do s.crt ZCNake on 1, it's going to ask me what folder it's in. It's in Usagi. And there we go, Centurion Snake by Rin14500, public domain. There's a bunch of comments at the beginning, and then this goes on for a very long time. And moving back and forth is going to be tough to explain it. So I think what we actually need to do is we need to print this out. And in order to print this out, we'll just do s.lst, and then we'll do ZCNake 1 on PRT 0. Okay, the printer's on. We need to hit the print button here to get the ready light up here. The motor's off, but that should kick on once it actually receives the file. So we'll go ahead and hit enter up here, and it should start printing. Uh-oh, we got an ATTN print, but the motor says it's not off. It is spinning. Well, that was very strange. It just didn't want to print at all at first, which is even more strange considering that it ran when parked. It would try to print, it would like print out part of one line, but it was all wrong, and then it wouldn't do a proper line feed after that. And I found that if I took the printer offline, did a manual line feed with the button on the front, and then put the printer back online, it would try to print the next line, but again, it was printing the wrong stuff. But I kept going kind of back and forth, and then it started to print a little bit that seemed correct, and then it started to print more, and then it started to print more, and then it was totally fine. And so I quickly jumped over and told it to print out the code listing, and all 9 bazillion pages of this code listing printed with no problems whatsoever. So I have absolutely no clue what was going on in there. I don't know, I think just old computers and old electronics require a certain amount of anxiety from the user before they'll work, and I walked in here with just a little bit too much confidence, and so it worked really hard to bring my confidence level down to 0 and shoot my anxiety level through the roof. And as soon as it deemed that I was so anxious, I was sweating bullets, it said, all right, here you go, here's your code listing. So, I don't know, maybe next time I'll walk in with a little less confidence. But we have our code listing here, and I do want to walk through it because, well, there's a couple of things really fascinating about this. The first is the first line here. It says Centurion Snake by Rin14500. I did not write this Snake game. This was written by Rin14500. And Rin is one of the most talented programmers I have ever met. Putting programming aside, he's just one of the nicest people that I've ever had the pleasure of hanging out with. So Rin, if you're watching, thank you so much for absolutely everything. I really enjoy our time just chatting and talking about all sorts of vintage computing stuff. You're just awesome. Thank you so much, dude. But the code that you wrote for this is on another level because Not but 2 years ago, we had no clue what the instruction set of the CPU was. We didn't even know if we had an operating system. And in less than 2 years, Rin managed to completely reverse engineer the entire instruction set. Not only did he fully reverse engineer the instruction set, he managed to write a multiplayer co-op CNake that runs on bare metal in pure assembly and actually assembles on this machine, the real hardware. And Rin did it all without having the real hardware at his disposal. So there was a couple of tools that made that actually possible, chief among which was Meisaka's unbelievably good emulator. Meisaka's emulator runs the genuine CPU6 microcode. It is web-based, so if you want to use the Centurion and you don't have original hardware, you can hop on any web browser and use the real Centurion microcode through a proper emulator. And so using that, Rin was able to write one of the most stunning pieces of code I've seen in my life, because what it took to get here is insane. Starting at the top of the code here, everything is fantastically commented. Every single line has a comment, so even if you've never seen Centurion assembly before, you can actually look at this and figure out what's going on. The next big thing that I want to point out is this line right up here says, everything before game name is part of GOS, Game Operating System. Rin essentially built an entire operating system dedicated to building more games in the future. This is pretty epic. But as we move down through the code, there's a lot of really important things that are just being handled for us right off the bat, like setting up interrupts. Every time that a player presses a key, that sends an interrupt to the CPU, and so the code has to handle it, and that's all set up right through here. And then we get down here to current CRT information. And this is another thing that GameOS does for us that I think is really fantastic, is that it abstracts the data terminals. So you don't need to know the actual function tables for each type of data terminal, whether I'm using an ADS or a VT100 or an ADM3A. It's all already built for us in GameOS right here in the beginning. But moving on here, we can actually see that abstraction in work. So for example, if we need to beep the current CRT, we just call the beep subroutine, and it takes care of all of that for us by pushing stuff to the stack and loading the A and doing all of the stuff for the specific CRT that you're working with. Same with clear screen and positioning the cursor. It's all abstracted, makes it super easy. So this is actually a large portion of the code, just getting this CRT abstraction going on. We can see there's ADS and ADM and VT100. This is multiple pages of code to get that coding. But once we get a couple of pages down, we get here to print the welcome screen. And the welcome screen in this situation is written out in ASCII art, and it's just using DC to define characters, and he's using C's and E and N, T and U, R, I, O, N to spell Centurion. But after we print the title screen, we jump to a subroutine to print the game name, and then we fall right into handling the welcome screen menu. So essentially, this is where the user is going to set up the parameters of the game. And they have a couple of options here. They have C, L, K, S, and B. And depending on what the user presses, we jump to specific different things. And so if the user presses the character C, we jump over here to CRT configuration. So you can see that it's, 75, 300, 1200, 2400, 4800, 9600, or 19.2 baud. So you could have multiple data terminals plugged in running at different baud rates, and it's all just totally handled by GameOS. And then the next option that somebody has to press from the main menu is L. And L is the layout of CRTs. And this is actually important for gameplay because you can build multiplayer games with CRTs in different configurations. And you can change the layout of how it is so that way the CRTs connect in different ways. And then at the welcome screen, if the user presses K, they can set up their key configuration. And this is the control keys that they're going to use to control the character on the screen. I personally like WASD, but this collection of assembly here allows you to set it up to whatever you want. And then we move right on down here to speed configuration. This is configuring how fast the game is going to run. Particularly for Snake, this is important because it's controlling how quickly our snake is moving across the screen. And finally, if the user presses B at the main menu, we start to actually run the game. But before we get into the proper game loop, there's a bunch of stuff that we have to actually take care of first. And we can see that right here at the beginning. So we actually push X to the stack, but all other registers are going to get obliterated here. We clear A, load it with 3, store that into the game score. That's the initial length of the snake. And then we draw the borders around the edges, which is actually quite difficult because the borders are going to change depending on the layout of the CRTs. We initialize the game board, we set the game speed, and then we finally get into the meat and potatoes of it. But to do all of that, there's a bunch of code that goes along with it. Like this is the collection of code that is used to draw the borders. And you can see the borders are just going to be a bunch of stars along the edges. And so once the borders are drawn, we need to initialize the actual game board here. And again, we can see we have a wonderful little note up here that says clobbers all except X. That's actually quite important for writing very complex assembly like this. But once the board has been initialized, the score is set, we're in the proper game loop now. So we load up the previously set game speed so we know how fast we're running, and then we wait for a preset time or until a key has been pressed. If a key has been pressed, we jump to this subroutine right here, which handles that key press. And it handles it for, it checks left first, then it checks right, then it checks up, then it checks down. And then we move on to the next section that is to update the direction. So we load up the snake length and position, and we calculate the new snake position, and then we dive into checking if food is in the new position. And that's what this collection of code is going on. There's multiple parts of it, and it takes up about 2.5 pages. But essentially, if there's no food present, we check if there's a border. If there is a border and it's hit, we go to game over. But if there is not a border, we check if we've hit ourselves. And if we hit ourselves, we go to game over. But if we didn't hit ourselves, we finally jump back up and actually update and move the position of the snake. However, if there is food present, we jump down to this section here, which is eat the food. So we need to draw a new head and draw a new segment behind it. Then we need to create new food someplace else on the map, and then we check if max score has been hit. So if you get to a max score of 128, you win. It just prints game over and takes you back to the welcome screen. And then that takes us to the end of the code listing, end of source, end entry. That is Game OS, one of the most stunning pieces of code I've ever seen. Well, now that we know the code, let's turn it into an executable so we can actually play it. Now, it's been a while since I've done this, so hopefully I can get the syntax right. But we'll do p.asm. The file was CNake, but the assembler here automatically prepends the Z, so we just need to do CNake. That's on platter 1. We don't want it to show us everything that happens when it does the assembly, so we're just going to say dummy here. And then I think we have to have an X here on the end. Again, it's been a while. So we'll try this. And then it's going to ask me what folder it's in. It's in Usagi. And here we go. We'll see if this actually works. It gave me a WP1 there. That I forgot to turn write protect off on the Hawk drive, so I flipped the switch off. Hopefully that didn't cause any issues. There we go, no errors into ASSM. Run X-Link, so we're doing the linker stuff, and yeah, we're all done. So we should have an executable. I don't know if it's going to be in the Usagi folder or if it's going to be in the main folder here. It looks like it's going to be in the Usagi folder, so let's do .dir.usagi.1. Should be all the way at the bottom here, CNake. Okay, so I tell you what, let's go ahead and just copy that executable over to root. So we'll do s.copy CNake1 to CNake1. The in library is Usagi. The out library is nothing. All right, so this should run. So we need to get back to the D equals prompt. So I'll hit select on the front panel here. We'll tell it to H1. It should give me a name equals prompt after this. And we're gonna do CNake. That's on disk 1. There is no code, so we hit enter, and yes! Oh, that looks so cool. CNake 1.1 on GOS 0.4. There's all of our options, and we need to set this up. But this is multiplayer Snake, and I mean, you can play it single player, but that's not nearly as much fun. So let's pull out a couple of other terminals. Maybe I can hunt down a buddy, and we can get some multiplayer Snake going on. All right, I got my good buddy Chris here. We're both actually sitting down because otherwise I'm so much taller that I can't get us both in the frame at the same time. Not that you're short, it's that I'm just dumb tall. But Chris came down for the eclipse, so say hi to the people, Chris.
How you doing? Really great to be here. Appreciate the opportunity and your hospitality.
Yeah, man. How was the eclipse yesterday?
The eclipse was outstanding, once in a lifetime chance, or maybe twice in a lifetime for me. I went back in 2017, it was great. First time for him though, so.
It was epic. It was pretty epic. I only took one picture, so I'll show that one, but it was pretty awesome. But I have Chris here. I've got 4 data terminals plugged into the Centurion. What better time to play multiplayer Centurion Snake than right now? However, with just 2 of us and 4 data terminals, we're gonna have to do a bit of double duty. So Chris is gonna get those 2 over there. I'm gonna get the main one and the ADM behind me. And we're gonna see if we can get 4-player Snake going on with just 2 people. But first things first, we gotta actually get the game running and set up for all 4 terminals, and that should be a little interesting. Before I started filming, I wanted to make sure that all 4 data terminals work, and you can see they're listed right here. CRT0 is this data terminal, and then 2, 1, and 3 here are the remaining data terminals. And the reason that they don't line up with the order over here on the left is that I initialized the data terminals in a different order, and so they actually just show up in the order that you initialize them at. But the important thing here is that we've got 4 functioning data terminals on this Centurion minicomputer. So we need to go back here. I'm going to push the select button to get to D equals. We're going to do H1. It's going to get us to a name equals prompt. From here, we'll type CNake. Then we'll hit disk 1, no code. Should load us up into Centurion here. And then if we do CRT configuration, so we'll hit C here. And we'll start with CRT1. And that is also going to be 9600, and it is an adds terminal, so we're going to do 0. All right, that brought us back to the main menu, so we'll hit C again. The CRT number now is going to be 2. That again is going to be 9600 baud, and this time it's the ADM, so we'll do 1 for ADM. And there it goes, it updated the ADM3A with our title screen here. The final terminal is CRT3, so I'll hit C here, and then 3. Now this is the data terminal that I have from VCF, and I haven't figured out the blinking issue on it, but if it runs at 4800 baud, it doesn't blink. So we're gonna set this up for 4800 baud, and it is also a adds data terminal. And there we go, that updated that one too, excellent. All right, next we need to set up the key configuration, so I'll hit K here. CRT0 is gonna be my CRT. I like up to be W, left to be A, right to be D, and down to be S. So I'll do K again for CRT1. This is one of Chris's terminals, and he wants O for up, K for left, semicolon for right, and L for down. That seems crazy pants to me, but it is what it is. So I'll set the other 2 up right quick with those key layouts. 3 is you again. That's weird that you don't have a down. That is not correct. All right, the final thing we need to do is set up the layout. So I'll hit L here for layout, and it says CRT number left to right, and then we hit 8 when we're done. And the ADM3A is CRT2, then CRT0 is this one, and then CRT3 is the VCF terminal. That should have taken 4. Why did you not take 4? All right, we had a little bit of difficulty. I don't know if it's the ADM's fault or if it's the fact that we were trying to run 4 data terminals and it only works with 3 data terminals. But either way, we've eliminated the ADM and we're just 3 adds terminals and 3-player with 2 people. But I think we've got it figured out. So we'll go ahead and hit B to begin game here. You ready?
Yes.
All right, I've got the snake and the food.
Okay, all you.
That's all me.
All you.
All right. So we'll get the snake over here, pick up my $sign, which is food. I don't have the food this time.
I have the food.
Okay, you've got the food.
All the thirds, all
the way over, all the way over.
Yes.
So I'll hold the key down and put the snake into hyper mode. You've got control on the second terminal now. Yeah, okay,
right,
go get the food. All right, coming in on the third terminal here with the food. Yeah, we got it. I've got the food over on my terminal. Okay, all the way back over to here.
Why did this one not work? Because it wasn't on that screen. And now it's yours.
Oh, now I got it. Okay, so we got my $sign over to here.
Okay, I got it.
On which one?
Middle.
You got that on the middle screen. Okay, we're going back over to the middle screen. You got it.
Okay, another one here. Snake's getting longer.
It's getting longer. We're up to 13. We got to score 13. I got it. Don't crash into yourself.
Exactly.
You almost did.
I almost did. I'm not a lefty.
All right, I got control from here. All right, who's got it? Far right?
Oh my gosh, all the way over, yeah.
Oh, you got it in the bottom right corner.
It's in the corner. It's gonna kill me.
You're good. That's all you.
I'm not doing turbo this one. This is against the wall.
Oh, you missed it.
Oh, and I can't.
Oh, that's rough. You got to circle around now.
There we go.
Oh, you got it. Oh, no!
I hit up.
Oh, you were too slow.
Oh, man.
We only got 15 points. We can do so much better. All right, Chris, that was ridiculous.
It was crazy.
It was pretty awesome. Have you ever played multiplayer co-op, Snake?
Never in my life. First time.
That was awesome. Rin, you're a genius. But we got to somehow figure a way to get this up to like 32 terminals, because that would be bonkers. Right?
Yeah.
Especially with 2 people to have 32 terminals, it would be an absolute riot. Chris, I want to thank you so much.
Absolutely.
I mean, you're not going anywhere. I'm going to turn the cameras off. We're going to continue to hang
That's right.
out,
And we're going to probably play some more too.
Yeah. But after Chris goes, I got one more thing that I want to take care of. So I'm going to do that next for you guys. But that's actually going to happen later for me, because I'm going to go back to playing a bit. All right, there's one more thing that I want to do here, and I want to get this game onto a floppy disk. And that may seem a little strange because I'm pretty sure that I'm the only one with a functioning Centurion at this point, but this is a pretty remarkable milestone in the history of this machine. This is the first game that's been written for it in 40 years, and I'm pretty sure it's the first time that Snake has ever been written for it. So let's commemorate it by putting it onto a floppy disk. And I've got a new floppy in there. It's a single-sided double density floppy. You can see I had used it for something else at some point in time and it's all messed up. So we need to new disk it. So we'll do s.newdisk, and it's gonna ask us the disk number. That's gonna be disk number 2. And it says guarded, so we need to no guard it first. .noguard2. Then we can do an s.newdisk onto, and then the new disk name is going to be CNake. And yes, we are ready. Now this is going to take a little while because writing floppies is slow, and it has to essentially format the entire floppy and then confirm that it's all good. So I'm just going to sit here and let it do its thing, and it should let us know when it's finished. All right, looks like it's finished. Let's do .dir2. And yeah, we've got the Whipple on there, so this should be technically a bootable floppy. It should at least get us to a little bit of a prompt. But we need to put a couple other things on there. We need to put @load on there. That's that name equals prompt. So let's do s.copy @load from 1 to @load on 2. And that's not in a library. And so we're just gonna let this copy. There we go. That took like 10 minutes. I forgot how slow floppies were. But we need to get Snake over there now. So we'll do s.copy xCNake 1 xCNake 2. Those aren't in libraries. And away we go. There we go, that went way faster, and we can see why. That when it copied over at load, that took up 5 tracks and 12 sectors, but XCSnake only took up 12 sectors, so it was a much smaller file. So if we do a .dir2, we should see the WIPL, which is all these SLOD, SDIR, swallow, and then atload and XCSnake are the two things that we need to make this bootable from bare metal. So now all I need to do is hit the select button. That'll get us back to a D equals prompt. We'll do F0 to boot from the floppy here. This is going to boot us to that name equals prompt using that atload file that we copied over. And there we go. We'll just type XCNake, and then that is going to be on disk 0. There is no code. We'll hit enter, and there it goes. That is running completely off the floppy. No need for a hard drive to be spun up at all. You can now play Snake on a Centurion if you only have a floppy drive. That's pretty epic. Now all we need to do is print out or make a label for that floppy disk. Where there's a will, there's a way, and Rin had the will to write the first full-fledged video game for the Centurion in over 40 years. But I would consider this the first full-fledged video game for the Centurion, full stop. This is absolutely stunning. And we even put it on a floppy disk, and I even printed out a little label for it using the Data 100 printer. I just taped the sticker to the paper in there, and it seems to have worked really well. It almost looks professional. That came out looking really good. But everything that was done today was done without having the genuine Centurion hardware at hand. Rin programmed and designed this entire thing using nothing but a text editor and Meisaka's unbelievably good emulator. Meisaka's emulator is web-based and anybody can use it, and it runs the real deal Centurion microcode. So it's about as close as you can get to using a Centurion without actually having a Centurion. And Rin's code is in the public domain, so anybody can use that code as a foundation to build whatever they want, any kind of new game that they want. And the fact that Game OS kind of abstracts all of the terminals, it makes it really easy to start going from there. We also have the entire instruction set reverse engineered into a couple of files with unbelievable documentation about them. So you can learn Centurion assembly and program Centurion games with all of the resources that we have freely available. Now, unfortunately, there's not that many Centurion pieces of hardware out there, but I do want to do something to get real deal Centurion hardware into the hands of people, and I'm imagining something kind of like a PyDP, maybe a Raspberry Pi in a 1/16 size case or something like that. That could get real deal hardware into people's hands, and then they could play these games. They could play Centurion Snake on real deal hardware with a real deal terminal. I think that would be absolutely epic. But today was a ton of fun. I had a blast playing multiplayer Snake, and I want to thank you all so much for watching, and I hope to see you in the next episode.